See, already we discussed when delta G is negative means that is a spontaneous process. Okay, delta G is positive, spontaneous process. When delta G is positive means non-spontaneous process. Okay, non-spontaneous process that we discussed last class. Right now, right, when delta G is negative means what happened in the case of delta S? Delta S, you know from the equation delta G equal to delta H minus T delta S. So that delta S is positive. Delta S is positive means your delta G is negative, right? So when the delta S positive, for example, the delta S total positive means you know that total delta S equal to delta S system plus delta S surrounding, right? When delta S is positive, your reaction is a spontaneous reaction. You know what is a delta S means? It depends on the system entropy and the surrounding entropy, right? So here very easy to find it what is the entropy of the system because that is in our control, right? We find it entropy of the system, but entropy of the surrounding is very difficult to find it because the influence is more, not only the only one factor. Okay, lot of factors decide the entropy of the surrounding. Therefore, we have to new terminology terms. It required to find the entropy of the surrounding. That's why we can go for the Helmholtz free energy, Gibbs free energy, everything. Okay, Helmholtz free energy and Gibbs free energy. There we can calculate the what is the free energy available or else what is the unconverted energy. Okay, what is the rest of the energy, how much energy we supply to the system. For example, 100 kilojoule per mole we supply to the system means 40 kilojoule per mole is used by the system to start work, okay. The rest of the 60 kilojoule per mole is a unconverted energy, okay, or else it won't give the useful product. So that 60 kilojoule per mole we have to find it based on the Gibbs free energy and Helmholtz free energy. Okay, that is a new technology term. That's why I told before the second law of thermodynamics we discussed only the enthalpy. Yes, enthalpy, internal energy. Like that term only we discussed. After the second law only we discussed the entropy, Gibbs free energy, Helmholtz free energy, everything. So here, what is a Helmholtz free energy and what is significance of that Helmholtz free energy? Okay, Helmholtz free energy or else Helmholtz work function. Okay, Helmholtz work function. The symbol is A. What is the symbol of enthalpy? What is the symbol of enthalpy? H. What is the symbol of internal energy? Symbol of internal energy. U or E. Okay, internal energy. Okay, and Helmholtz work function A. Gibbs free energy. What is the term? What is the symbol? G. Yes. Okay. Right. What is a Helmholtz work function means? What is a for example, you know the equation A equal to E minus Ts. Okay. That means This is a Helmholtz work function. What is a Helmholtz work function means? A part of internal energy. Somehow I write it very shortcut, otherwise I dictate. You write it. What is a Helmholtz work function? A part of internal energy of a system what is a Helmholtz work function means? A part of internal energy of the system can be used to do some useful work at constant temperature. Because if you weighing this, that means the system start work means delta A equal to delta E minus T delta S. So that system start work when at constant temperature. You can do the reaction, whatever the reactions you are doing at constant temperature. So here T is constant, the system start work. Okay, that is a definition. A part of internal energy. We supply the 100 kilojoule per mole, but all the 100 kilojoule per mole is not converted into the useful work. Only the fraction of internal energy, only we can use it to do the convert useful work, or else we get the product. So therefore the part of internal energy of the system can be used at constant temperature to do some useful work. That is which is isothermally available. That is called work function of the system. Okay, that is called work function of the system. That's why we given A equal to E minus Ts. Here we are doing the reaction or else the process at constant temperature. Therefore, delta A equal to delta E minus T delta S. Okay, minus T delta S. So, what is the significance of that work function? What is the significance of that work function or else Helmholtz free energy? Okay, Helmholtz free energy. So that's right. Suppose, for example, this you can take a equation 1 and equation 2. You start from here itself. A equal to E minus Ts. When system start work at constant temperature, the equation will be changed. Delta A equal to delta E minus T delta S. Right? But here, that instead of minus T delta S, you remember the earlier classes, what is the entropy equation? We know already. We know that what is the entropy equation? Delta S equal to what is the delta S? Delta S equal to Q reversible by T. So if you rearrange the equation, T delta S equal to Q reversible. Okay, suppose you consider this equation number 3. Right? So therefore you substitute the third equation into the second equation, what we get it? Substitute third equation into second equation. What we get it? Delta A equal to delta E minus Q reversible. Right? Delta A equal to delta E minus Q reversible. You got it? Right? Up to this, any doubt? Again, this one you are substituting the entropy changes. What is the first law of thermodynamics says? What is the first law of thermodynamics says? According to first law, delta E equal to Q minus W. What is the amount of energy you supply to the system minus what is the work done by the system? That is a change in internal energy, right? When the internal energy change, when the system start work, how much work done by the system, you subtract what is the total energy you given to the system. Therefore, delta E equal to Q minus W. Okay. Otherwise, you rearrange it. Delta E minus Q equal to minus W. Okay. Delta E minus Q equal to minus W. Just you rearrange it. Rearrange it. Suppose you consider this is equation number 4. Otherwise, equation number 5. You substitute equation 5 into equation 4. What we get it? Delta A equal to minus W max. Otherwise, W max equal to minus delta A. Right? W max equal to minus delta A. What is the meaning of this equation? W max equal to minus delta A. It means the free energy is less. That time you get the maximum work from the system. Yes, absolutely. When the free energy is less, otherwise the unconverted energy is less means you get the maximum product. You get the maximum product. W max equal to minus delta A. That is the meaning of this equation. Sometimes they ask explain the significance of Helmholtz work function. So that time up to here you have to write it. W max equal to minus delta A, which means when the free energy is less, we get the maximum work from the system. Okay. Any doubt? So just you substitute here. At the beginning you can take a delta A equal to delta E minus T delta S, where the T delta S you substitute using the entropy equation. Again you substitute according to the first law of thermodynamics says what is the internal energy change equal to total energy supplied to the system minus what is the work done by the system. You substitute, you get the delta A equal to W max. When the Helmholtz work function decreasing, we get the maximum product. We obtain the maximum product from the system. That's it. Right? What is the time? This one, as per the equation you write it. when delta A is decreasing, or else Helmholtz work function decreasing, Helmholtz work function decreasing, we obtain the maximum work from the system. We get the maximum work from the system. Helmholtz work function decreasing, we get the maximum work from the system. That's it. Okay, right. Now we go for the Gibbs free energy. Gibbs free energy. You know the Gibbs free energy, G equal to H minus Ts, otherwise delta G equal to delta H minus T delta S. Right? What is the equation says? Delta G means available energy. Available energy equal to total energy minus unavailable energy. Okay, so we have to calculate what is the rest of the energy. Available energy equal to how much energy we supply to the system minus what is the unavailable energy. Otherwise, how much energy used by the system. That we have to subtract. Let's say, for example, total energy 100 kilojoule per mole minus unavailable energy 40 kilojoule per mole. That means this much energy used by the system to do the useful work. 40 kilojoule per mole used by the system to do the useful work. What is the available energy? 60 kilojoule per mole. Okay. Rest of the energy is 60 kilojoule per mole. Once we know this information, then only we can analyze what we can do for the available energy to convert into the useful work. That information we need. That's why the Gibbs free energy very clearly explained to find the available energy. Okay, available energy. Then we can go for the analysis. What are the ways we can use the available energy to convert it into the useful work? First of all, we have to know okay, right, that is a Gibbs free energy say. Gibbs free energy to calculate the available energy, to find the available energy. Once we know how much energy is available, then we can find it what are the ways is there to use that available energy into the useful work for our system. Okay, right, what is the significance of this? Maybe similarly you can take it, this is the equation number 1, equation number 2, okay, equation number 1 and equation number 2. Then we go for the equation just we discussed delta A equal to delta E minus T delta S, right? Delta A equal to delta E minus T delta S. And one more equation also we know, delta H equal to delta E plus P delta B, right? P delta B. Delta H equal to delta E plus P delta B. Suppose you consider this a third equation, you consider this one is a fourth equation. Okay, just you substitute fourth into third equation. What we get it? Delta H. Sorry, you rearrange this equation. Okay. You rearrange this equation. Delta A plus T delta S equal to delta E. Now you substitute instead of delta E this one. Okay. So what happened? Delta H equal to delta A plus T delta S plus P delta B. Right? Am I right or wrong? Okay. Third, suppose this is a fourth equation means, listen, third equation, this is a fourth equation, I erase it. So you substitute now, instead of delta H, delta A plus T delta S plus P delta B. Okay. Substitute fourth equation into second equation. What we get it? Delta G equal to, instead of delta H only we have to write it, delta A plus T delta S plus P delta B minus T delta S. Now you cancel the common term. Delta G equal to minus W max plus P delta B, right? Instead of delta A, we write it minus W max, because the significance of Helmholtz work function says when we get the maximum work, when it decreasing the free energy. So therefore, instead of delta A, that means we know already W max equal to minus delta A. If you rearrange, delta A equal to minus W max. Okay, you substitute here, you get it. Okay, delta G equal to minus W max plus P delta B. So here we know we have to get the work maximum. When the work is maximum means you just change the sign both the side. Minus delta G equal to W max minus P delta B. P delta B, right? W max minus P delta B, because we have to get the maximum work from the system. When we get the maximum work from the system, delta G is negative. delta G is negative. So here, what is a P delta V says? What is a P delta V? That is work done by the system at constant pressure, the expansion of volume. When the expansion of volume means work done by the system, then only the expansion of volume is there in your container, right? So therefore, work done by the system, okay? Work done when expansion of the system. What is a W max says? W max is maximum work. We get the maximum work obtained from the system. Obtained from the system. W max equal to maximum work obtained from the system. What is a W max minus P delta V says? That is a net work, final work, okay? After completion of all the process, what is a net work? W max minus P delta V, okay? W max minus P delta V. So therefore, W max equal to minus delta G. When you do the work at constant pressure, you get the maximum work obtained from the system. W max equal to minus delta G, which means when the free energy of the system, if free energy of the system is negative or else decreasing, we get the maximum work from the system. At the final conclusion, what we can come? Helmholtz free energy, also Gibbs free energy. All the free energy is decreasing means we get the maximum work. Because there also we get the W max equal to minus delta A. Here also we get it W max equal to minus delta G. So therefore, available energy decreasing means we get the maximum work from the system. Okay, available energy decreasing, we get the maximum work from the system. Therefore, the P delta V is there, how much work done by the system when expansion of the container. W max is there, what is the maximum work obtained from the system? W max minus P delta V, this is that is net work. What is the net work of the system? So therefore, minus delta G equal to W max. That is at constant pressure. If we are doing the reaction at constant pressure, W max equal to minus delta G. So we have to write it, explain the equation. The derivation for your physical chemistry is not a very big issue, but how to explain that equation, how you understand that equation, that is the main. What is the information is there in that equation, that we have to explain. Okay, so similarly you write it, what we write it in the Helmholtz free energy. When decreasing the free energy of a system, we get the maximum work. Okay, we get the maximum work, or else we get the maximum useful product from the system when decreasing the Gibbs free energy. Okay, when decreasing the Gibbs free energy. Right. So this is one question. Maybe they ask the significance of Helmholtz free energy, otherwise significance of Gibbs free energy. Okay. after my lecture.
Now pause.